Today we're going to talk about a new unit, exponential functions, and we're going to start with just some basics, order of operations, function notation. So here we go. First, what is an exponential function? So how is it different than linear functions, quadratic functions, exponential functions? So we took a look at this at the beginning of the year, but linear functions are something like y equals 2x or y equals mx plus b, linear, straight lines. Quadratics are parabola-shaped graphs with an x squared term, like y equals ax squared plus bx plus c is standard form. So we've looked at those. So exponential functions kind of look like this type of curve. And they are of the format, they have a base and the x is actually in the exponent. Here the x is being multiplied by a coefficient, here x is being squared. Exponential functions, x is in the exponent. So the definition of an exponential function, a function in which a constant base is raised to an exponential variable. So in this case, x is the exponent. So we're just starting by evaluating. And so we could do this using order of operations or typing into a calculator. But I wanted to talk about the steps with order of operations. You always do parentheses first. So my first step would be doing 2 plus 3 to get 5. And then which am I going to do next? Am I going to multiply or distribute the exponent? I'm going to distribute the exponent and do 5 squared next. So I'd have 5 times 25 is now 125. So I can do it using order of operations without a calculator. Example 2 I put on here because you've got a negative number that's being squared. It's kind of like taking -1 and multiplying by 2 squared. You still do the exponent first. So this is really -4 plus 5 is 1. And I want to show you, if you type this into a calculator, -2 squared plus 5 is 1. That's what we got. Now what happens if I put the -2 inside parentheses and I square it and I add 5? This is going to give me 9 because I'm going to get +4 plus 5 is 9. So there's an important difference when the negative is in parentheses or not in parentheses. All right, so the answer was 1. On example 3, I'm going to do my parentheses first. So I have 1 times 4 squared. Now I'm going to do the 4 squared next. So 4 squared is 16 times 1 is 16. And the last problem, -3 times -3 is +9. 2 times 3 is 6. So I'm taking 9 and subtracting 6, and I would get 3. Part 2 is evaluating something written in function notation. So here is your exponential function. It wants you to plug in 0 and see what you get. So I'd have 2 to the first power, because 0 plus 1 is 1, and then I'm subtracting 3, and 2 minus 3 is -1. Now you should try plugging in 3, and then you're going to check your answer. So pause it and check your answer. So I'm going to do 2, 3 plus 1 is 4, minus 3. And 2 to the 4th is 16. 2 times 2 times 2 times 2 is 16. Minus 3 would give me 13. I wanted to show you how to plug this into your calculator so you could just quickly evaluate. So there's some steps over here. I'm going to type it into my y equals menu. So I've got -300 times 0.2 to the x power minus 3 in my y equals menu. I want to jump to -2 in my table. So I go to second window, which is table setup. I want to go to -2, second table. So at -2, the answer is -7503. -1, -1503. At 0, -303. At 1, -63. And then if you need to jump in your table to 20, you could scroll down, or go back to second table setup and just tell it to start at 20, second table. And it tells me that at 20, it says -3, but see how this decimal, it's really approaching -3. So it's not quite there. It's -3 with a really long decimal, but it's about at -3. We're going to see that it approaches an asymptote. So -3, it is approaching about -3. All right, I also wanted to talk a little bit about scientific notation, and then you're going to try this page guided practice on evaluating function notation using technology and scientific notation. So you're going to do the 345 guided practice at the end. So scientific notation, some of you might have seen in a science class. So it may be new to some of you, but many of you have seen it in your science class, or you will when you take chemistry. Scientific notation is a way to express a number as a decimal between 1 and 10, multiplied by 10, so you can write large numbers using less digits. So how is another way that we could express 93 million miles, which is the distance to the sun from the Earth? So we want to make it a decimal between 1 and 10, so 9.3. So what do I have to multiply by? 10 to what power? So if I was at 9.3, I would have to move my decimal 1, 2, 3, 4, 5, 6, 7 places to the right. So 10 to the positive 7th power would give me 7 places to the right. All right, how about 323 million? And I'm not sure how accurate this is right now, the number of people in the USA, but it was at one time. So I want to cut it down to a decimal between 1 and 10. So I'd have 3.23 times 10 to what power? So put your decimal point at 3.23. 1, 2, 3, 4, 5, 6, 7, 8. So it would be 10 to the 8th power because I need to slide 8 spots to the right. All right, this time I want to reduce this to a decimal 2.7 so that it's between 1 and 10. But I am starting here and I'm going to the left. So 1, 2, 3, 4, 5, 6, 7, 8 places to the left would be the -8th power. So for the right, you're going to use a positive power. And for the left, you're using a negative power. 365 would be 3.65 times 10 to what power? 1, 2. Change each of the following scientific numbers now into common numbers. So 3.6, 10 to the 6th says to slide that decimal 6 places to the right. 1, 2, 3, 4, 5, 6. So that will tell you how many zeros to put. So you'd need 5 additional zeros. So this would be what? 3,600,000 is 3.6 times 10 to the 6th. This time they want you to slide to the left. So 1, 2, 3, 4, 5. So how many zeros do I have to add? 4 zeros. 0.000032. And I always double check. 1, 2, 3, 4, 5 that I got the right number of zeros and decimal in the right place. 1 unit to the left would be just 0.068, right? I start at 6.8. Oops, I think I did it one too many actually. So it'd be 0.68, right? That's just one slide to the left. Multiply each of the following using proper scientific notation. How would I multiply these two together? So there is a little bit of a shortcut. You can take the 1.8 and multiply by 3.6. So you'd have 1.8 times 3.6 is 6.48. Now, if that number came out bigger than, 10, you might have to change it to scientific notation. But I'm going to have 6.48 times 10. How many zeros? A total of 7. So 10 to the 7th. We're going to talk about exponent properties a little bit more this unit. So if you didn't quite get this one, we'll go over how to do that a little bit more depth. What about division? So you can actually divide. 4 divided by 2 is 2. And think about if you have 12 of these on top and 3 of these on the bottom, you're actually going to cancel 3 of those zeros, right? 10, 0, 0, 0, 0, 0 divided by 10, 0, 0, 0, 0. You're going to cancel 3 of the zeros. So I would have 9 of the zeros left. So times 10 to the 9th. And again, if this is more challenging, try it on the guided practice, and we're going to go over that in more detail with exponent properties. All right, so here's a tough one. 6 divided by 2 is 3. But with negative exponents, you haven't seen those very much before, if not ever. So there is a rule for when you divide powers of 10. You take the numerator and just subtract the denominator. 12 minus 3 was 9. What is negative 6 minus negative 8? It's actually positive 2. And you can always check your answer using a calculator. Parentheses, 6 times 10 raised to the negative 6 divided by parentheses 2 times 10 raised to the negative 8th. 3 times 10 squared is 300, right? So you could always divide or multiply on your calculator and then convert it to scientific notation for now if you prefer. So now you're going to take some time and work on guided practice front and back of 345 and post it to Google Classroom. Have a great day.